Welcome to the last part of the periodic table. So in the previous videos we looked at a recap of the periodic table, the periodic trends, and then we started looking at group properties where we visited some special groups including group 1, then we moved to group 2, then we moved to group 7. In this final video we're going to visit group 8 and also transition methods. So by now you should have a general feel of the periodic table. You should know where the metals are, where the non-metals are, the trends, the periodic trends, what happens as you go down the groups among metals, what happens as you go down, as you go up the group among non-metals, what happens as you go along the period. So you should have that. Just to emphasize, as an emphasis, among metals, when you go down, the reactivity increases. Among non-metals, when you go up, the reactivity increases. Meaning that this is more reactive than this, which makes francium the most reactive element. And here, you expect this to be more reactive than this, because as you go up the group among non-metals, the reactivity increases. Also, when you are going from left to right, the reactivity decreases. What does that mean? It means this is more reactive than this. This is more reactive than this. This is more reactive than this, just like that. So that's just a general feel you should have about the periodic table. We're going to look at this special group here, group 0. So let's see the behavior. So group 0 elements, the other names are noble gases, innate gases, or rare gases. So innate usually means something that's not reacting. Rare, something that you cannot just, that is not everywhere, in short. So they are called noble gases or innate gases or rare gases because they are chemically unreactive and therefore do not form compounds. Because they do not form compounds, you cannot just find them anywhere. What are some of the chemical properties of group 0 elements? They are chemically inactive because they are full outermost electron shells. Okay, so this is the only chemical property of group 8 elements. They do not react. Why? Because they have full outermost electron shells. So why is it that because they are full outermost electron shells, why is it that they do not react? They do not react. How does having full electrons in the outermost shell makes them unreactive? So atoms tend to lose, gain, or share electrons. The act of sharing, losing, or gaining electrons is what makes a reaction possible. But these ones do not share, lose, or gain electrons, and therefore they do not react. Why is it that they do not do this? Because they have the maximum number of electrons in their outermost shell. So they are very stable and they do not need anybody to be stable. So that's the reason why they are not reactive. Because of this, again, they exist as unreactive monoatomic elements. The word monoatomic means they are made of a single atom. Group 7 elements are diatomic, meaning they are made of two atoms. How so? Because they are very reactive group 7 elements, they end up reacting with themselves to form an atom. To form a molecule, a diatomic molecule. So group 7 elements are always found in two. Chlorine, it's 2 chlorines. Fluorine, it's 2 fluorines, just like that. But for these ones, they exist as a single atomic elements made of a single atom because they do not combine even with themselves. Then what are some of the physical properties of group 7 elements? Number 1, group 7 elements are gases at room temperature and pressure. Number 2, they have a very low melting and boiling points. So if you look at the periodic table, these are the group 8 elements, which are all gases here. And because they are gases as compared to these which are solids, most of them here are solids, they are expected to have a low melting and boiling points. Remember, gases have particles which are far apart from each other because they are far apart from each other, the amount of heat that is needed to separate the particles is very small. Therefore, they have low melting and boiling. Uses of group 8 elements. 1. Helium is used to fuel weather balloons because of low density. So one of the physical trend among the group 8 elements is as you go up the group, they become less dense. So helium is on the top of the group, and therefore it is the lightest element in the universe. Because of that, it is used to fuel weather balloons, and because weather balloons, when they are filled with helium, they are light, and since they are light, they'll float up so that they are on top of all denser gases. The second application of group 8 elements is neon is used to fuel colored glowing tubes used in advertisements because it glows red hot in an electric current. So there are some cities, one of them of course maybe the famous being Tokyo, and even in Osaka there are some buildings which light up, like the name is lighting up, the name of the building or the name of the store is lighting up. So the lighting up is because of they are filled they are tubes which are filled with neon, and once current is passed in there, the neon glows. To glow is of course to emit light. Therefore neon signs are very used almost everywhere, and that's one application of group 8 elements. Argon is used to fuel light bulbs to provide an innate atmosphere to prevent the oxidation of the filament. So there are those light bulbs which we used to use in the old days. Maybe some houses still use them. I don't like them because they consume a lot of electricity. But I'm not talking about energy savers. I hope you know what I mean. Those Philips bulb, old bulbs. So those ones, they have a filament which is a metal inside. That filament is the one that emits light. So that filament, when it reacts with oxygen, it goes through a process called oxidization. When that happens, it's going to lose its properties, and therefore it won't be able to emit light. So the light bulb is filled with argon, which is not reactive, so it's going to cover the filament such that no any other gases such as oxygen can reach it, because argon is very unreactive and doesn't combine with these other elements. We now move to transition metals. So transition elements are found in the center block of the periodic table, between group 2 and 3 and between period 4 and 6. So transition metals are these here, from here to here, from here to here, from here to here, and even these here. So these are just an extension of this, because if we put these elements here, then the periodic table cannot fit here and it won't look as beautiful as it looks here. So these are transition metals. They have very strange behaviors. So let's take a look at here are some physical properties of transition metals. One thing about this, as we are studying these physical properties, you should keep in mind that they're just metals. So the properties of metals should apply to transition metals. First, they have high densities. They are metals, so expect them to have high densities. They have high melting and boiling points. They are good conductors of heat and electricity, just like any other metal. They are solids at room temperature and pressure, except mercury, which is a liquid. So there is a metal which is a liquid, and it's mercury. So it's the only metal which is a liquid. It's a metal, but it's a liquid, mercury. It's the one that they use in the thermometer when they're measuring your body temperature. Inside, there is a metal, but it's a liquid, the mercury. So when you are reading the thermometer, the liquid that shows you what your temperature is, that's mercury. It's the only liquid which is a metal. They are ductile. So ductile, like I explained in the previous video, it means they can be drawn into thin wires easily, and they are malleable. To be malleable means they can be hammered into thin sheets. So you can get a hammer, you can hammer them till you have thin sheets. Let's take a look at chemical properties of transition elements. One, they are catalysts. So they are very good catalysts. A catalyst is a substance that speeds up the rate of the chemical reaction without itself being changed at the end of a reaction. So they are very good catalysts. They have variable valences and form positive charged ions. The second part of forming positive charged ions, we are all aware of that because it's a metal, it's going to lose electrons and it will form positive charged ions. But the part for variable valences, that's a new part. Let's look at copper. So when you are studying valences, copper, which is written like this, copper 1 has 1 as a valence, and the one that is written like this, copper 2 has 2 as a valence. Copper is a transition metal, silver is a transition metal, iron is a transition metal. So they have variable valences. They change, the valences keep on changing. They form colored compounds depending on the valence used. So copper 1, if it is involved in a reaction, what's going to be formed is going to have a certain color, and copper 2 also, if it is involved in a reaction, the color is going to be different. For example, copper 2 compounds are blue, iron 2 compounds are pale green, just like that. They are reducing agents because they lose electrons. Just like group 1 and group 2, they are all reducing agents because they lose electrons. What are some of the uses of transition elements? They are used to make electric cables because they are good conductors of electricity. We know we use copper cables to have electric cables. They are used to make pots and pans because they are good conductors of heat. They are used to make alloys. Alloys is where you get two different metals, you mix them so that you have a blend of properties from those two different metals. So transition metals are very good in making alloys. They are used as catalysts in the industries to speed up reactions. So this is one of the properties that we had talked about, and therefore that's one of the applications.